Hi folks, welcome to my talk. Today I'm going to be talking about designing APIs and when less data is more. I'm super glad I could present to you all today. I'm sad that we're not all together at a nice location where we could all meet up, but at the same time, it's great that we could all join this conference from across the globe. Let me introduce myself. My name is Damir Svrtan, my pronouns are he, him, and I work as a senior software engineer at Netflix, where I spend most of my time building APIs. I'm recording this from San Francisco. That's where I'm currently based and where I moved about 3 years ago. Prior to moving to San Francisco, I used to live in Zagreb, the capital city of Croatia, a small country in southeastern Europe. That's where I grew up. I spent the first 28 years of my life, and where I used to organize a local Ruby meetup called Ruby Zagreb, so a big shout out to all the members of the community there. Now, why is this topic relevant to me? I've been building APIs for the last 7 years, and I've seen a pattern where developers like to expose more data than is actually needed. I want to talk about avoiding overhead when designing APIs. And what kind of overhead? I want to talk about avoiding building bloated, overly flexible APIs with queries that nobody asks for, endpoints that nobody's using, generally unused functionality like extra fields, extra relationships, all of these things that developers try to be speculative of what's going to be needed in the future, that they build up front, that they have to maintain, and that nobody's using. Now, what kind of APIs am I talking about? I'm talking about HTTP-based APIs, such as REST APIs, JSON APIs, even GraphQL, and so on. But this talk is going to be API technology agnostic, and it's going to be applicable for all kinds of APIs. Through this talk, we're going to be building a blogging platform, something similar to Medium or Dev.to. It's going to be fairly simple. It's going to have authors that can release posts, and it's going to have posts that can have comments. Now we're going to talk through two principles for building APIs. The first one being designing the minimal API surface, or how not to overexpose data on your APIs. And then the second one is going to be designing from strict to loose, or how to avoid building extra flexibility that nobody asked for. So we're going to start with the first principle, designing the minimal API surface. Generally, I see a pattern where developers try to be speculative about what's going to be needed in the future, so they often overbuild their APIs. I'm going to break this into three patterns of a bloated surface that I usually see. The first one is redundant fields, then it's redundant relationships, and then it's redundant input fields. So let's start off with don't expose redundant fields. Let's imagine we have a requirement from our product management and it says we need to show the author of the blog post. Now let's say we're storing authors in some kind of a database and it's got an ID, it's got a first name, a last name, an email, and an avatar URL. Now, if we check out the design that we have, and this is literally from Medium, we can see we've got an avatar, we've got the first name, we got the last name. We're not exposing an email here. Now, the friendly API developer that's building this API might say, now let's expose the email. Somebody might find it useful in the future. Why wouldn't we expose the email field right away? If we're gonna need it in the future, possibly, we're gonna spend more time exposing it than if we need it afterwards, right? So we're technically saving time for the business. Well, given this thought, the friendly API developer might, expose an author resource that has that email field. But what happens if we need to actually remove that field in the future? Let's say for privacy reasons like GDPR or California privacy laws, we need to stop exposing that email field because it's just not data that we're using or that our apps are using. Now, we gotta go through a deprecation cycle. We need to mark that field as deprecated if our API schema descriptors allow for that. Or if we have a versioned API, we might need to release a new API version actually. And then we got to go through extreme amounts of communication. We got to send out emails reaching out to clients. And if we're building a private API, let's say we have only a couple of clients. Let's say we have a web client, and then we've got a couple of mobile clients, like an Android and iOS client. That's a smaller amount of them, but it's still a lot of communication and coordination nevertheless. But if we have a platform API where we have, tens or hundreds or thousands of users, this thing gets really hard, and we got to give a few months of lead time. We got to send out an email that we're deprecating this by some date and that clients are supposed to migrate off of it. And then we're potentially breaking clients. Really depends on what kind of API we're building. If we have an API where clients can pick and choose which fields they want, something like GraphQL or sparse field sets in JSON API specification, we might be, pretty good if nobody's using that field, but we do have to have metrics and observability to understand that nobody's using that field. But if we don't have any kind of like this pick and choose methodology or sparse field sets, and every time somebody requests an author, we always give back all the fields, you technically don't have any idea whether you're breaking clients or not. And then we gotta go through extreme amounts of redundant cycles, multiple deploys for marking the field as deprecated, then testing it out on a test system, then deploying it to production, monitoring that nothing got broken, and so on. So it's not just as easy as removing a few lines of code. The technical execution of it in terms of like coding wise is really easy, and anybody can do that. That's super easy. We gotta remove it from some kind of a serializer, some kind of a resource annotator. We have to remove tests for it, and that's about it, and we have to deploy. But actually the communication aspect and the coordination is where it gets tough. Now, the second part that I want to talk about in this first principle is not exposing redundant relationships. It's really similar to not exposing fields, but with a couple of quirks that are different. Now, let's say we have a requirement that says we need to indicate whether a post was reviewed. Let's say, we're building out this new feature that's called reviews, where certain blog posts get reviewed. They get a green check mark next to their title, so our users actually know that they have been peer reviewed and that they are trustworthy. Now, let's say our post resource on the API just has a title and a body, both of type of a string. And we decide, okay, we need to expose the reviewed Boolean field, which is okay. Now, our friendly API developer might say, let's expose the reviewer, like the person that actually reviewed it, just for future use cases. If our clients will need it, they won't have to wait for us to deploy it, and we won't have any work to do now. And so we decide, okay, let's expose the reviewer field as well. But now, what did we actually do with this? Our development costs are growing. We need to either batch or eager load it, or maybe lazy load it. It really depends on how you're tackling your N+1 scenarios. And then we gotta also test it out. But besides testing, there's also potential of negative performance impacts. Again, it goes back to the case whether our clients can pick and choose fields they want to use. Now, if we got sparse field sets or this kind of thing in GraphQL where you can pick and choose, it might be all right. Maybe nobody's actually using that field, hopefully. But if we don't have something like that, and every time we load the post, we load the reviewers as well, we're adding extra time for that response time when we're retrieving a post. So it's got negative performance impacts. And besides that, we're also adding maintenance impacts because every time something changes to the reviewer technique or kind of reviewer logic, we also have to update that. And it's for a thing that actually nobody wanted to use and nobody asked for. And what happens if we decide, or if our product decides that we don't have one reviewer anymore? We're going to have multiple reviewers. And we're actually going to expose who are the people that reviewed this post. A totally kind of a revamp on the feature that we had initially. Now, again, it's the same as the one before. We got to go through a deprecation cycle. A lot of communication, emails, Slack messages, and so on. and we're potentially breaking clients. If we remove that field, hopefully we know that nobody is using it anymore. And if we leave it there, while there are multiple reviewers, people might not get absolutely the correct data. And then there's one thing we are not utilizing, and that's delaying decisions. Generally, when building software, it's better to delay decisions if we can without impacting, roadmaps, than it is to make premature decisions. What if we decided not to name it reviewers? What if we decided to name it totally different? What if the type is not reviewer anymore? What if it's just user or something like that? The later we add these things, that's better because then we have more knowledge. And that's just the absolute. In general, it's easier to add in future than it is to remove. I've been through this many times where I was removing stuff that nobody asked for. And I guarantee it's way easier to add in future than it is to remove. Sometimes additions to APIs can be done within an hour. You got your API clients asking you to expose an extra field, and you can literally deploy it within an hour and can hit production within an hour. Well, removals are never as easy as that. You gotta, as said again, you gotta reach out to all of your clients, make sure that they are not using it, or if they're using it, they gotta spend additional cycles on removing it. Now, these two topics about not exposing redundant fields and not exposing redundant relationships was about queryable resources. Let's talk about when we need to mutate data. So don't expose redundant input fields. What kind of input fields am I talking about? I'm generally talking about the payload your API accepts when it's mutating or changing data. In REST APIs, that would be the data that your API gets whenever a client initiates a post or a put request. Let's look at an example. Let's say again, our product manager says that we need to enable our readers to create and update comments. Now, we build out an input that's called create comment that defines two fields that our clients can send out when they want to create a comment. They send out a post ID and they send out the body. Now, the friendly API developer might say, let's just have parity between inputs. Whatever we exposed on the create comment, let's expose it on the update comment as well. Well, now we have the ID of the comment that is actually getting updated. We got the post ID and the body. But all that we ever needed was an ID and a body. And I've seen this done many, many times, and it really doesn't make a lot of sense. First of all, the schema is bigger. So our clients also need to think how they're going to communicate with this. And we need to build extra logic on the back end. What do we do if they send the same post ID? And what do we do if they send a different post ID? Our blogging platform doesn't support common transitions from one post to another. Why would we support a signature like that in our API? Could you even imagine that we actually build a UI where comments can be transitioned from one post to another? Could you actually imagine that, we build a UI like that, we spend product cycles on something like that? Realistically, what happens, if it ever happens, if somebody posts a comment on a wrong post, what they do is they copy it, they delete it from the original post, they paste it into the desired post and just submit it, and that's it. So pretty easy. So why would we actually build something like this? Generally, I would say avoid anemic data modeling. Surely the create comment input has a post ID. Even the comment resource probably exposes a post ID as well. But it doesn't mean we are able to update it. These do not have to match. You're supposed to build your apps and your APIs according to your business needs, and that logic should be on the server, not on the client. A really great blog post about this is on Medium, and it's from Mark from GitHub, and he talks about GraphQL mutation design and how to avoid anemic mutations. It's not only about GraphQL, or you can apply it to anything else, but it's a great read and I recommend reading about it. And then lastly, this kind of ambiguity deteriorates developer experience. You're confusing your API clients, They can ask themselves, what happens if I send the same value? What happens if I send a different value? They might reach out to you to figure that out. And now you're just spending time on a thing that wasn't even supposed to be there. And then lastly, you ain't gonna need it. Just don't expose it. Okay, so that's about it on the first principle. The second principle I want to talk about is strict to loose. And I'm gonna break it out into two categories. The first one being avoiding extra flexibility, and the second one, breaks first, or how to apply defensive programming to your APIs. So let's talk about avoiding extra flexibility. What you want to do is have your APIs be ready for extra flexibility in the future, but they don't need to be extremely flexible for now, especially if there is no need for that. What you need to do is scope out what is needed for your clients. Now let's imagine we again have a requirement that says the users need to be able to see comments on a post. Pretty reasonable, right? Now, let's imagine we build some kind of a query or some kind of an endpoint that's called comments, and it should realistically just accept the post ID that is supposed to be required. Now, the friendly API developer might say, our clients might want to fetch all comments in the future. So let's just enable them to not send that post ID. Let's make that post ID optional, So what did we actually get with this? We're building unneeded application logic. Now we need to handle both cases, when there is a post ID and when there is not a post ID. So kind of something like this. And in general, more code means more maintenance. Anytime you change some commenting logic, you need to reflect that in both scenarios. And what about if you have caching to kind of level up your performance? Are you going to have two strategies? And is one of those strategies going to be on a thing that you even didn't need to build? And then more code means more tests, because you got to test both cases in this scenario. So on inputs or on payloads that you receive on your API, it's easy to go from required to optional, not the other way around. Or even better to say, strict to loose, strict being required and loose being optional. Strict to loose gives you more control. It gives the client less flexibility, but it's not the flexibility they ever asked for. And it gives you more flexibility in terms of changing. If at first you marked it as required, you can always remove it and mark it as optional, and your clients are going to be able to communicate just fine. While the other way around, loose to strict, is a breaking change. Let's say you built it out as optional at first, and then after a year you realize, we've been changing this part of the code so often, business logic changes, requirement change, we just don't want to support this anymore. So you decide to actually make that post ID required because you don't want to care about that logic. Well, now that's a breaking change. Okay, and then lastly, the second part of the second principle, and that's defensive programming. So you need to ensure that your API is not going to get abused. Let's go with the same example. We need to have the ability to fetch comments for a post, or generally show comments for a post. Now the friendly API developer might say, let's just give them an array of comments to our UI clients, or to our API clients, We don't need pagination, or even a better version of this. We don't need pagination yet. Now, we decide to build it as just an array of comments with no pagination. And the friendly API developer might explain this to themselves. We won't have more than 5 comments per post. And then 6 months after, there's posts with hundreds of comments. I'm sure some of you have experienced this. I have experienced this myself. Previously, I have built something that I thought there's not going to be more than 5 of these things. And then 6 months to a year after, there were 200 of these things and I needed to change stuff. So the developer says, let's add pagination. Great. And so we add some kind of paginated comments. Really, the syntax doesn't matter here, or the implementation. But now it's potentially a breaking change. Or we need to introduce a new query and a new endpoint and somehow deprecate the old one. Or we don't deprecate the old one, and then we have to support two scenarios. And some of our clients might be working more slowly because of this. So the friendly API developer might say, work is done, let's go home. Well, not so soon. Let's imagine that the client was too lazy to actually do paginated requests and just says, give me the first 1,000. Well, realistically, what the friendly API developer didn't do is the friendly API developer didn't add limits to pagination. Generally, adding pagination limitations from the beginning should be the best practice that you're striving for. You can always give an error message that says something like, we can return 1,000 of these things, we can only return 100 of these things. And these limitations are super hard to add retroactively, but they're super easy to adjust in the future. If let's say we didn't have any kind of limitation, or the limit number was really high, like 1,000, and we realize, oh no, this is like exhausting our server or something like that. If we go down to, let's say, 100 or 50, that's potentially a breaking change. But if we started with 10 and our clients said to us, it would be better for us to, kind of iterate over this if it was 20, we can adjust that, and that's not a breaking change. Okay, so that's about the principles that I wanted to talk about. Now let's talk about how to avoid these overheads. Well, first of all, you should adopt schema-first design. Figure out what is your domain and for whom you're building your API. Don't play guessing games. Don't couple your API to specific implementations. Maybe today you have a relational database that is backing some of this data, but tomorrow it might be some API that won't have the same fields, and you might bring yourself more trouble than anything. And then talk to your clients. Involve them early in the process. Figure out what their needs are. Don't try to be speculative. You don't have to build this whole thing up front. What you need to do is be iterative. And thus you need to be also responsive to your clients' requests. Your clients need to know that they can ask you to add more stuff, and you're flexible and you're able to do it, in a timely manner. Now, there's always exceptions to these rules. Two things that come to my mind when you're building a minimal API schema, or when you potentially want to make an exception to these rules, is if you're building maybe a platform API. There might be a little bit of speculation here if you're building and you don't know your clients and you're trying to get ahead of competitors and try to drive user adoption. But even then, I would question how much this kind of speculation is actually worth. And it's probably bringing you more trouble than it is bringing you more benefit, And then you might have weird constraints due to release cycles. I have a coworker that worked on an API that was deployed on premises for their clients. And they would release these APIs once every 6 months, and they would have to do thousands of deployments every time they released. And so the clients actually integrated on premises as well. So if they missed a field that a client might need, they would have to repeat the same redeployments, which would be really costly. Now, this is a very unique situation and you're probably not in it. So this really shouldn't apply to you. Okay, in conclusion, what I want you to take away from this talk. Redundant work like this slows down progress on important features. You might be able to spend your time more wisely by improving API documentation, by improving slow queries, and etc. Exposing too much data can be highly unproductive. There's a saying, the road to hell is paved with good intentions. Even though we might think we're doing something good for our API clients, so we're building stuff upfront for them so they can just be flexible and do their stuff without involving us, that's often not the case. Our business is not benefiting from this, and our API clients are probably not benefiting from this. Thank you all. this is all from me. If you want to talk more about this topic, let's talk afterwards or reach out to me on Twitter. Thanks.